Alright, hello, welcome to another beautiful lesson in Algebra 2. So we're going to finish up our um, talking about factoring and then ultimately wrap up polynomials with a very important theorem. But before that, I want to talk about one thing that we just discussed earlier today, where you were looking at this long division to solve a real world problem. So I'm just showing here the work that I went through to get through the long division. And as you see by the name, long division is pretty long. And so the idea is that we want to in some way cut down the number of steps and the amount of work that we're doing, because eventually we'll get to problems that take a while. So we want to do whatever we can to find a simpler way or a quicker way to get through the problems. So here, what I'm going to show is another way that we can divide, get the same answer, but it's a little bit quicker, and it allows us to do our last factoring method, which we need just in case our other methods of factoring don't work. So we're essentially about to talk about a unique combination of factoring and division that helps us wrap up our unit or our unit on polynomials. So this is what we call long division. There is another type of division we call synthetic division. So what I'm going to do is work through this same problem using synthetic division, and I want you to see how it takes less work to work through. So I left off my N in synthetic. But the idea is just in the name. Synthetic is just the idea that you're taking this kind of artificial, so to speak, method of doing something that's not natural, but it kind of mimics the actual process of dividing. So we're going to take what we're dividing by. So similar to long division, we were dividing by x plus 2. And so in synthetic division, we only use numbers. So in this case, we're only going to use our solution here that will make this 0. So negative 2 plus 2 is 0. So we're going to use a negative 2. And it just so happens that we usually just change the sign for this. So whatever linear term you're dividing by here, you just use the opposite number. Then inside our house, notice that the house is now a little upside down. So that's another way we kind of flip that long division idea on its head. Now we're talking about synthetic division, so we switch the house kind of. Then inside, again, we're only using numbers. So instead of writing this entire polynomial, I only use the coefficients. So for x cubed, how many x cubes do I have? Well, I have 1. For 6x squared, how many x squareds do I have? 6. That's the coefficient. How many x's do I have here? I have 12. That's the coefficient. And then the number 8 will be the last thing. If I were to be missing some exponent here, let's say I didn't have this term, then I would use a 0 instead of 12, because I don't want to skip any exponent or polynomial term exponents, because that throws off the synthetic division. So hypothetically, if you were to have that, you want to use a 0. Alright, next I'm just going to show you the process of the synthetic division now. So the first thing you're going to do, you're going to bring down the first coefficient here for our x cubed term and write that below the line. Then we're going to start a process of multiplying. So the number on the left here gets multiplied by the number at the bottom. That gives us negative 2. Then we add these two numbers. 6 plus negative 2 is 4. Then we start over with multiplication. So the number here on the left, negative 2, we multiply by the new number on the bottom. Negative 2 times 4 is negative 8. Then we add this 12 and negative 8 to give us another 4. Again, we multiply the number here times the new number on the bottom. Negative 2 times 4, which is negative 8. And then once again, we add 8 and negative 8, and we're going to get 0. So this final number, once we can't add anything else tells us our remainder. And these numbers are the coefficients of our quotient. So we're going to reduce our exponent by 1. So we started with the exponent of a term of x cubed. So we're going to reduce our term, rather, the exponent of our term. So this is going to start with x squared. So we have 1x squared plus 4x plus 4. That is our quotient. And so remember that that's exactly what we got when we were using our long division here. But just look at this as a comparison. So this is all we had to do for the long division, and this is what we had to do for the synthetic division. Right? So the process is slightly simpler because we don't have to deal with the variables anymore until we want to know our final quotient of, or the results of dividing. So synthetic division is a method that we're going to be using as we talk about our last method of factoring. So this last method of factoring works for everything, but it takes the longest because it's when any other method fails. So if we can't find a GCF, if we can't use a special formula, if we can't factor by grouping, this is the last method that we would use to factor. So let me give you an example of this last method of factoring. So let's say you get you're given a polynomial that you want to factor. X cubed minus 4x squared plus x plus 6, and you want to factor this. Well, you've gone through all the methods that we've gone over. You've tried factoring by grouping, that didn't work. You see that you can't use a special property because there's 4 terms. And what else? I think those are the only 2 we talked about. And you can't use, of course, like any of the quadratic ways of factoring because this is not a quadratic. So what you would do here is you're looking at 2 different key things here. So one, the leading coefficient here is 1. So you want to think, okay, what are my factors of 1? Well, that's pretty simple. It can be a positive or a negative 1, plus or minus 1, because 1 times 1, that's 1, and negative 1 times negative 1, that's also 1, okay? So don't forget about both the positive and negative factors. For 6, so we're going to do this for the leading coefficient and the constant here. Focus. Okay, here we go. And so then we write out all the factors of 6. Well, of course, it's 1. Then 1 times 6 is 6. Then 2 times 3 is 6. So we have plus or minus 2. I said 3. 3 times 2 is 6. And then finally, 6 times 1 is a factor. So these are all the factors of 6. Alright, next is when it gets a little bit tricky. So in order to find what we call possible factors, we're going to take the last term, or our constant, the factors of our constant here, 6, and divide by the factors of our leading coefficient, which is 1. And we're going to see what we're going to get. So when we divide, we kind of got a lucky case here because 1 divided by 1 is going to be 1 still. 2 divided by 1 is still 2. 3 divided by 1 is still 3. 6 divided by 1 is still 6. So in this case, none of these numbers are going to change. So all of our factors, possible factors, are going to be the same as the factors of 6. Okay. So there are 8 different numbers here that I can try to be able to factor this polynomial. Okay. So a factor just tells us a number that, or a term that we can multiply to get the entire polynomial, or it's a way that we can find the roots if we were to solve for x. So we can think about these possible factors as just solutions to this polynomial. So if I were to plug these back into this polynomial here, I should get 0 if they're real solutions. So I'm just going to try a number here. So let's just try 1. I'm plugging this into the polynomial. So everywhere I had an x, I'm going to replace it with a positive 1. So this is going to give me 1 minus 4 plus 1 plus 6. Well, if I were to add these together, I'm not going to get 0. So positive 1 doesn't work. Okay. So let's try negative 1. So I'm going to replace all my 1s with the negative 1. So as I work through this, feel free to pause it so that you can check to be sure, yeah, that doesn't work. Okay, let's try negative 1. Negative 1 cubed is negative 1. If I were to square negative 1, I'll get a 1 times 4. That's negative 4 because of the subtraction sign. Plus 1 is minus 1. Plus negative 1 is minus 1. And then plus 6. I'm going to add these together. That'll give me negative 5. Negative 1 plus 6 is 5. Well, that gives me 0. So I can confirm that negative 1 is a factor here. Or rather, negative 1 is a solution. So I just want to confirm that with some synthetic division. So that was the purpose of talking about that synthetic division before. So I'm going to put in the negative 1 and all my coefficients. 1, negative 4, 1, 6. So remember, I bring down the 1, multiply, add, multiply, add, multiply, add. So I'm going to get x squared minus 5x plus 6 is a factor. So that tells me that I had the negative 1 was a solution. So that means x plus 1 was a factor. Now I have x squared minus 5x plus 6 is a factor. Then I can do the same here, and I can find my factors of x squared minus 5x plus 6. I know x squared I can only get by multiplying x times x. And then 6, multiples of 6 are positive and negative. So I'm just going to try some factors and see if that works if I FOIL. So x times x is x squared. X times negative 3 is negative 3x. Negative 2 times x is negative 2x. That works. That gives me negative 5x. And then negative 2 times a negative 3, well, that's a positive 6. So here I have found all the factors of this polynomial. So yes, it is a long process, but this is if none of the other methods work. So there is no special case or formula. Factoring by grouping doesn't work. This is the last resort. So if no other method of factoring works, then this is the process that we would go through to find the factors of a polynomial. You can rewind, rewatch this video, slow down, look over it, whatever you need to do. If you have any questions or concerns, let me know.